Welcome to Maths and Science Professor channel, and today we are still looking at statistics and we are looking at Spearman's rank correlation coefficient. We can use Spearman's rank correlation coefficient to calculate the correlation coefficient R between variables. For example, variables X and Y, where X is the grade point average while Y is the graduate record exam score. We have the grade point average and the graduate record exam score. We want to find the correlation coefficient between this set of data, X of Y. In calculating R is 1 minus 6 times the summation of D squared over n into n squared minus 1, where d squared is the square of the difference between the ranks in the variables that we have, while n is the number of the set of variables that we have. For example, in our case, we have x is 8.3 and y is 2.3, and x goes up to 8.6. Y, the graduate exam score, is 2300 for x 8.3 and 2250 for x 8.6, and this continues up to 8.6, 2260 for x 8.6. What we do is we have the ranks for the set of data that we have. For example, for different entries of data that we have. For example, if we have x is 8.3, we want to rank from the largest to the smallest, where the largest becomes the first rank and the smallest becomes the last rank. Now that we have this set, we have these entries 8.3 to 8.6, we will check and find out which is the largest. And in our case, 9.8 is the largest. Now it is the first rank. We proceed and look at the next data entry that is following 9.8. We find out that is 9.2. 9.2 has the second, 9.4 has the second rank. We proceed and we have 9.2 having the third rank. As we continue, we find out that the next one is 8.6. 8.6 will have the fourth rank. We also have 8.6R2. Now this would have supposed to have occupied the fourth rank, and maybe this would have occupied the fifth rank. What you do when you have data entries that are similar, you look at the ranks that they are supposed to occupy, that is the fourth rank and the fifth rank. If you add 4 and 5, that is 9. You divide, you find out the average, and the average is 4.5. Now this will be assigned rank 4.5, and this will also be assigned rank 4.5. Now the fourth and the fifth rank has been occupied. Now the next rank will be rank 6. We have 8.6. We proceed. We will now have 8.3. 8.3 will now occupy the sixth rank. We have 8.0. 8.0. Before 8.6, we have just made a mistake. Before 8.6 occupying the fourth rank, we were supposed to have 9.0 occupying the fourth rank. Now that we have 9.0 occupying the fourth rank, meaning 8.6 and 8.6 were supposed to occupy the fifth and the sixth rank respectively, or otherwise. But now we'll have 6 and 5, 11. The average is 5.5. 8.6 will be given rank 5.5. 8.6 will be given rank 5.5, and then this will be given the seventh rank. We proceed. We find out the next rank is should be rank 8. 8.0 is now assigned at the 8th rank. We have 7.0. We'll assign it the 9th rank, and this one will be assigned the 10th rank. Now this is rank X. Let's proceed and find out rank Y. The same. We follow the same procedure and give ranks from the largest to the smallest. Now, the largest data entry is 2400. 2400 will have the first rank. The following entry is 2380. 2380 will have the second rank, and the next one is 2360 will have the third rank. The next one is 2350 will have the fourth rank. Then the following is 2300, which have the fifth rank. Then we have 2250, 2260. 2260 will have the sixth rank. And then we have 2100, which will have the seventh rank. 2260 having the sixth rank. This one will have the seventh rank, and then this one is supposed to be the eighth rank. Then we have 2000 and 2000 supposed to occupy the ninth and the 10th rank respectively, but then we had 9 plus 10 to have 19. The average is 9.5. Now they have ranks 9.5. We go ahead and find D. D is the difference between the ranks. We have 7 and 5. The difference is 2. 5.5 and 7. We have the difference is negative 1. The difference is negative 1.532. The difference is 1. It is 0. Negative 1.5 1. Negative 1, 0, 0.5, negative 0.5. D squared. Now square the difference between the ranks, where we will have 4, 1.5, we will have 2.25, 2.25, 1 we will have 1, we will have 0, we will have 2.25, we will have 1, we will have 1, we will have 0, we will have 0.25 and 0.25. We now find the sum of the D squared. The sum of the D squared will be 14, will be 12 if we add 2.25 plus 1 plus 0 plus 2.25 plus 1 plus 1 plus 0 plus 0.25, 0.25. We found out that we have 12. We go back to our formula and say that R is equals to 1 minus 6 times the summation of D squared over N into N squared minus 1. 1 minus 6. The summation of D squared is 12, N is 10, 10 squared is 100 minus 1. If we work out this, we find that our value of R is 0.9272. Now this is how you use Spearman's rank correlation coefficient to find the R, the correlation coefficient between two sets of variables. For example, our set of variables was between X was the grade point average, while Y was the graduate record exam score, and we have found out the correlation coefficient between a student's grade point average X and the record exam score Y is 0.9272. This is a positive correlation coefficient.